What if I told you that everything you see around you, literally everything, makes up only 5% of the entire universe? It sounds crazy, right? But that's just the beginning. Today we're diving into 10 of the most insane, unbelievable, mind-blowing facts about space that are 100% real. I spent the last month digging through astrophysics textbooks, scientific papers, talking to actual astronomers, just to bring you these facts. This isn't your average school science lesson. This is the stuff that will make you question everything you thought you knew about reality. Number 1. All right, let's start with something huge. I want you to picture every beach on Earth. Think about the Sahara Desert, the Gobi Desert, every single sandbox in every playground in the world. Now imagine counting every single grain of sand. It's an impossible number, right? Scientists have tried to estimate it, and they think it's somewhere around 7.5 quintillion grains. 7,500,000, 1,000. That's a 7, followed by 18 zeros. But here's where it gets absolutely insane. That massive, unimaginable number is nothing compared to the number of stars in the observable universe. When astronomers point their most powerful telescopes at the sky, they see galaxies upon galaxies stretching out in every direction. Each of those galaxies contains hundreds of billions of stars, some have trillions, and there are an estimated 2 trillion galaxies in just the part of the universe we can see. So, when you do the math, the lowest estimates suggest there are at least 1 septillion stars. Slow. 1 septillion. That's a 1 with 24 zeros after it. That means for every single grain of sand on our entire planet, there are at least 100 stars out there. Just let that sink in. We are talking about a scale that is truly beyond human comprehension. Next, number 2. Okay, so we've talked about the sheer number of stars. But what about what happens when they die? Some massive stars don't just fade away. They go out with a bang in a supernova explosion, and what's left is a neutron star. And when I say weird, I mean it breaks all the rules of normal matter. This is where things get heavy. Imagine a star much bigger than our Sun collapsing under its own gravity. It squeezes so much that protons and electrons are literally forced together to become neutrons. The entire star, once millions of miles across, is crushed into a sphere about 12 miles in diameter, roughly the size of Manhattan. You have the mass of a sun crammed into the space of a city. So, what happens if you could somehow get a piece of this stuff? Let's say you had a magical, indestructible spoon and scooped just 1 teaspoon of neutron star material. How much would it weigh? Not even close. That single teaspoonful would weigh around 1 billion tons. That's the same as 900 of the world's largest cruise ships or Mount Everest. You literally could not lift it. Place that teaspoon on Earth and it would punch through the crust, mantle and core, oscillating until it settled. Its gravity destroying everything around it. Next, number 3. If you thought neutron stars were the end of the line, you were wrong. For the most massive stars, gravity keeps crushing until collapse into a singularity. Nothing, not even light, can escape. This is a black hole. Over 100 years ago, Einstein predicted accelerating masses would create ripples in space-time. He called them gravitational waves. Imagine dropping a bowling ball onto a trampoline. The fabric ripples outward. Now imagine 2 cosmic bowling balls, black holes, spiraling together and crashing. Their collision is the most violent event since the Big Bang, releasing more energy than all the stars combined in a fraction of a second. Those waves travel at light speed for billions of years, and we built a machine to detect them. LIGO. 2 massive L-shaped detectors, miles long, sensing distortions smaller than 1/10,000th the width of a proton. In 2015, LIGO detected the faint chirp of 2 black holes colliding 1.3 billion light-years away. Play actual chirp. We had confirmed Einstein. We are literally listening to echoes from before dinosaurs existed. These detections opened a new way to observe the universe. We can feel its vibrations as well as see it. And this fabric of reality, it gets even weirder. Number 4. Get ready for this one, because it's going to mess with your perception of reality. We think of time as a constant, right? 1 second is always 1 second, no matter where you are. But according to Einstein's theory of relativity, that's completely wrong. Time is not absolute. It's relative, and it can be stretched and squeezed by gravity and speed. Let's start with gravity. The stronger the gravitational pull, the slower time moves. This isn't science fiction, it's measurable. GPS satellites are farther from Earth's gravity, so their clocks run about 38 microseconds faster per day. If scientists didn't account for it, your GPS would be off by several miles within a single day. Imagine you're on a planet near a supermassive black hole. The gravity is so immense that time would be drastically slowed down for you. You could spend 1 hour there, and when you return to Earth, decades or centuries could have passed. Speed also affects time. If you could travel at 99.9% the speed of light for what feels like 1 year, when you return to Earth, over 22 years would have passed. This is the famous twin paradox. It means astronauts on the ISS are aging ever so slightly slower than we are. There is no universal clock ticking the same for everyone. Your personal experience of time depends on where you are and how fast you're moving. The universe has a speed limit, but it plays fast and loose with time. Next, number 5. We're used to a very orderly picture of the cosmos. Planets orbit stars, moons orbit planets. It's like a neat, tidy cosmic dance. But the universe is a lot messier. In the dark, cold voids between stars, there are cosmic orphans wandering all alone. These are rogue planets, also known as interstellar planets, not gravitationally bound to any star. During the chaotic early days of a solar system, a young planet can get into a tug-of-war with a giant like Jupiter and get flung away like a slingshot. Or some form alone, from clouds too small to ignite into stars, failed stars. Whatever their origin, they wander in perpetual darkness and extreme cold, with no sun to warm them. It's a lonely existence. They don't shine and have no parent star to light them. But astronomers are clever. Using gravitational microlensing, when a rogue planet passes in front of a distant star, its gravity briefly magnifies the star's light, a tiny fleeting signal we can detect. Based on these detections, there could be an unbelievable number of rogue planets. Some studies suggest there could be more rogue planets in the Milky Way than stars. Our galaxy could be teeming with these dark, wandering worlds. Next, number 6. When you think of weather, you probably think of rain, snow, wind. On Earth, that's pretty much the whole story. But on planets around other stars, weather gets taken to a whole new, terrifying level. Take HD 189733b. It looks like a beautiful blue marble, but the color comes from silicate particles, the stuff of glass, in its atmosphere. Winds blow over 5,400 miles per hour, 7 times the speed of sound. It rains glass sideways. On WASP 76b, an ultra-hot Jupiter, the day side reaches 4,350 degrees, hot enough to vaporize metals. Iron becomes gas on the day side. Winds carry it to the cooler night side, where it condenses and falls as liquid iron rain. It literally rains molten metal. On Uranus and Neptune, immense pressure may squeeze carbon into diamonds that rain toward the core. Some carbon-rich exoplanets could have surfaces covered in diamonds and graphite, while we're here worrying about drizzle. The universe makes horizontal glass storms, showers of molten iron, and oceans of liquid diamond. A reminder, our gentle Earth is one possibility in a varied, often violent cosmos. Next, number 7. We've been throwing around big numbers, but now the biggest, the size of the universe. When you look up, you're seeing light that traveled years to millions of years. The farthest light we can see is from about 13.8 billion years ago, when the universe began. You might think that means 27.6 billion light years across, but you'd be wrong. While that light traveled, the universe expanded. Space itself stretched, carrying the source much farther away. Taking expansion into account, the edge of what we can see is about 46.5 billion light-years in every direction. That makes the diameter about 93 billion light-years. If the Milky Way were the size of a coin, the observable universe would be the size of North America. And that's just what we can see. Our observable bubble. We don't know what's beyond the edge. The universe could be 100 times bigger, 1,000,000,000,000 times bigger, or infinite. We just don't know. Because it looks uniform, it likely continues beyond our horizon. We're probably a tiny patch in a cosmos with no end. Thinking about this scale is almost impossible. Okay, this is one of the biggest mysteries in all of science, and it's a fact that should shock you. Stars, galaxies, planets, black holes, nebulae, all the stuff we can see, makes up less than 5% of the total mass and energy in the universe. Let me say that again. Everything you know, everything you see, is less than 5%. The other 95% is a complete mystery. The biggest mystery in science. Scientists call it dark matter and dark energy. They are dark not because they are black, but because they don't interact with light at all. Completely invisible to our instruments. So how do we know they exist? We see their effects on the 5% we can see. Dark matter, about 27%, explains why outer stars in galaxies move too fast to be held by visible matter alone. There's an invisible halo providing extra gravity. Then there's dark energy, about 68%. In the late 1990s, astronomers found the expansion of the universe isn't slowing down, it's accelerating. Something is pushing space apart. We call it dark energy. So, to recap, 5% normal matter, 27% an unknown invisible substance holding galaxies together, 68% a mysterious energy pushing the universe apart. We live in a cosmos where 95% is stuff we don't understand. We've talked about how big the observable universe is, but what's the single biggest thing inside it? A galaxy? A cluster? Not even close. The largest known structure is the Hercules Corona Borealis Great Wall, a colossal collection of galaxy clusters. It's so big, it breaks our current understanding of the cosmos. It's a great wall, a vast filament of galaxies, dark matter, and gas, held by gravity. It's estimated to be 10 billion light-years long. Our Milky Way is 100,000 light-years across. This is 100,000 times bigger. It was discovered by mapping gamma-ray bursts, powerful explosions from dying massive stars. Astronomers noticed a strange clump of GRBs in one sky region, implying a massive underlying structure. According to the cosmological principle, the universe should be roughly uniform on very large scales. No structures larger than about 1.2 billion light-years. There hasn't been enough time since the Big Bang to assemble something so enormous. Yet, there it is, almost 10 times bigger than the theoretical limit. Its existence challenges our models. Either our early universe understanding is wrong, or there's a mechanism for building such structures we don't know about. It's a cosmic monster that shouldn't exist. For our final fact, let's zoom in on the supposed empty space between stars and galaxies. We call it the vacuum, a perfect nothingness. But interstellar and intergalactic space is not empty at all. It's a fizzing, bubbling place filled with invisible things that affect the cosmos. Space is filled with a faint glow, the cosmic microwave background, leftover heat from the Big Bang, created 380,000 years after it began, travelling ever since. On an old TV, about 1% of static is the echo of creation. Space is also filled with stray particles. Neutrinos, ghost particles from stars and supernovae, stream through you by the trillions each second. And stray atoms, mostly hydrogen and helium, that never join stars. Density is tiny, a few atoms per cubic meter, but across cosmic volumes it adds up. At the quantum level, a perfect vacuum isn't stable. It's a boiling soup of virtual particles popping into and out of existence. These fluctuations happen everywhere, all the time. So the nothing of space is actually a something. It's filled with ancient light, ghost particles, stray atoms, and a constant fizz of virtual particles. A true, perfect void doesn't seem to exist. Even the darkest depths are alive. So there you have it. 10 facts that prove our universe is bigger, heavier, weirder, and more amazing than we could ever imagine. From stars outnumbering grains of sand to invisible matter and energy that make up 95% of everything, the cosmos is full of mysteries that challenge our perception of reality. We learn that time is not constant, that it can rain glass and iron on other worlds, and that even the emptiness of space is buzzing with activity. It's a lot to take in. The best part is that we are just beginning to uncover these secrets. Every new discovery, like the detection of gravitational waves or the mapping of the Hercules Corona Borealis Great Wall, opens up 1,000 new questions. We live in an incredible time where technology is catching up with our curiosity, letting us probe the deepest, darkest corners of the cosmos. The more we learn, the more we realize how much we don't know. We, a collection of atoms forged in the hearts of long-dead stars, living on a tiny rock orbiting one star among septillions, have developed the ability to look out and piece together the story of the universe. In a way, we are the universe becoming self-aware. If you enjoyed this journey, make sure to subscribe so you don't miss our next adventure. Thank you for taking another journey with me through our cosmos. And remember, keep looking up. Thanks for watching.